All right. Sorry, Daniela. Daniela called me out and said I always say all right, and I can't think of what else to say when I start the videos. So, all right, today we're going to start um, with 5.4 notes, the last notes, and today we're going to prove and use properties of triangle and their midsegments. So, firstly, we need to figure out what the heck a midsegment is. Mid kind of sounds like middle, and segment, we know that's a part of a line. So a midsegment is it's a segment, a part of a line that connects one midpoint in a triangle to another midpoint. So what that looks like is if we have a triangle, one midpoint, let's say I found the midpoint of this side, of side AB. I'm going to call that D. So D is the midpoint, and how can I show that it's a midpoint? I could put those tick marks. Then if I found another midpoint of another side, let's say I found that this is the midpoint, I'll call that midpoint E. So E is the midpoint of BC. So I put two tick marks. Now I put two tick marks because this side could be totally different length than this side. So let's say this entire side was 8. Now this piece would be 4 and this piece would be 4. They're still congruent to each other. Now this side's 8. This side could very well be 5 for all we know. And half of 5 would be 2.5 and 2.5. So this one tick mark means that those are congruent to each other, and these two tick marks mean that those are congruent to each other. And together that does not mean that AB is congruent to BC. Okay, so if I connected those two midpoints, I would get line segment DE, and that is considered a midsegment. So I'm going to give my example DE. Now, some cool things happen with DE. If you kind of look at DE, and AC, there's a special relationship between them, and that relationship is that they are parallel. So of course there's a name for that. That's called the triangle midsegment theorem. So the triangle midsegment theorem says that the midsegment is always going to be parallel, excuse me, I don't know why I put equals, is always going to be parallel, that's the sign that looks like two lines, to the opposite side of the triangle. So since DE and AC are opposite of each other, they do not touch at all, those will always be parallel. Pretty cool. Another thing that's cool about the midsegment, there's two things that are cool. The other thing that's cool is that this segment is exactly half of this segment. So if, let's say I told you that this side length was 8, this midsegment was 8, well that means that this whole entire thing would be 16. So how they write that is they say that the midsegment will always be half of the entire opposite side. Okay, so those are two really neat things. One other neat thing is there are going to be 3 midsegments in a triangle. So I'm going to erase this, but I'm going to redraw it for you guys. So obviously, if we have 3 sides, we're going to have 3 midsegments. So if I redrew my triangle ABC, and then I told you guys about there's a midpoint, I think that was D, right? Then we have midpoint E, and we have midpoint F. And midpoint, so I'll put my tick marks. Oh, yeah. I didn't draw this last time, sorry. Then we have one more midpoint because we have 3 sides. Okay, cool. Now this is one midsegment, so DE is a midsegment. EF is another midsegment, and this one would be parallel to its opposite side, AB. And then we have a third midsegment, DF. And that midsegment is parallel to BC, its opposite side. So we have 3 midsegments, and together those 3 would be called a midsegment triangle. So if they draw all 3 for you, that's called a midsegment triangle. So this is your midsegment triangle. And there's something special that happens between the midsegment triangle and our original triangle ABC, but we'll talk about that later. Today we're just going to introduce and use properties of the midsegment. So for number one, it wants us to find a side length BD. I'm going to scroll up just a little bit. Okay, so I want us to definitely remember these two theorems because or these two cool properties because they're going to help us with 1 and 2. Find BD. BD is a midsegment. So what I'm going to do is since I'm talking about how long a side is, I'm going to use this second equation. And I know that this midsegment has to be half of whatever the opposite side is. So this is the opposite side because they don't touch and they look parallel. So since this entire thing is 17, that means BD has to be half of 17. So I think that would be what? 8.2? 8.5. Okay. So BD is 17 over 2 or 8.5. Let's say I told you that BF, let's add on to this and make it a little bit harder. Let's say I told you that BF is 5 and I wanted you to find out what CE is. Well, BF is this one right here. BF is the midsegment. It's the shorter one, so it's going to be half of whatever the longer opposite one is. So we're going to look at this one. So that means that CE has to be 10. Another question I could ask you is what happens if I don't want to know about CE, I want to know just about CD. Well, if you notice, we just said that this whole entire thing was 10. So and CD is the midpoint, so that means CD is half of this entire thing. So CD would also equal 5, and this part would equal 5, and 5 plus 5 makes 10. Okay, so those are the types of problems I can ask you regarding side lengths. And the other type of question I could ask you involves angle measures. So if you notice number 2, it says find the measure of angle CBD. CBD is right here. Now, for angles, you're going to use this first property, that midsegments are parallel to the opposite side. And sometimes this is hard for people to see, but so I'm going to highlight it for you. Notice that this angle touches this side of the triangle, and the only other angle they talked to you guys about was angle 26, this 26 degrees. Notice that that angle touches this midsegment. These two yellow lines, the midsegment and this opposite side, they are parallel to each other. And we learned in chapter 3 that these two angles they look like a Z, so they make those alternate interior angles. So they're congruent. This is an acute angle and this is an acute angle. So this would be 26 degrees because of alternate interior angles. All right, I want you to try your best on 3, 4, and 5, and number 6 as well. And then we're going to actually apply this. That's the last thing we're going to do. So what if your job when you grow up is to find the width of a volcano? Crazy! Of course you don't want to go across this dangerous volcano by yourself and, measure it with rulers. So we're going to use the midsegment theorem to try to find out how long this triangle is. So you guys go to a safe area, right, in the forest, and you guys measure safely that this is 1,005 meters and this is 640 meters. And then you measure it again, another 640 meters, another 1,005 meters. That means H is a midpoint and F is a midpoint. Since it's a midpoint, we can safely figure out that if I know that this is, I didn't look it up in the book, sorry, so I'm going to make up a random number. Let's say that this comes out to be 1,300 meters. You safely measure this, that HF is 1,300 meters. So now you can safely, without risking your life, find out that the width of the volcano, AE, is going to be double that 1,300 because that's the relationship between the midsegment and the opposite side. So 1,300 times 2 is going to be 2,600 meters. So again, midsegment theorems, triangle midsegment theorem, super awesome. It could save your life one day if you have to measure the width of a volcano. Awesome. Fun fact of the video. Chimpanzees are the only animals that can recognize themselves in a mirror, besides us, of course.